Hello students, welcome to another wonderful session, that is multiplication of two vectors. Many of you have in your mind whether the vectors can be multiplied as we have added them, subtracted them. Yes, for your question there is an answer. Vectors can be multiplied. So vectors can be multiplied not in a single way. Vectors can be multiplied in two ways. So there are two important methods having their own geometrical, mechanical, engineering applications, and they are the scalar product, which is also called dot product, and the vector product, which is also called cross product. So today we will be discussing in detail, pin to pin, what is the scalar product of two vectors. So let's begin. So consider here, so look at this. There are two vectors A and B, and they are non-zero because they have some particular magnitude. And let us see, the angle between them is theta. So if this is the condition, means if A and B are two non-zero vectors and intersecting at an angle theta, then the scalar product of the two non-zero vectors A and B, it is denoted by this vector A dot vector B, and it is defined as like in this way. Vector A dot vector B is magnitude of A into magnitude of B into cos of the angle between them. Okay, so in this way you can define the scalar product or dot product of two non-zero vectors. And this dot, you don't treat it as a simple multiplication. It has its own meaning. So it is a symbolical representation of two vectors in scalar form. Okay, so you will be dealing with much on this as the time proceeds. Okay, so where theta is the angle between vector A and B, and its value is always between 0 and pi. So minimum 0, theta can vary up to 180 degree. So let's see here. In what case this product is not defined? So if either A or vector B is 0, it means one of the vector is 0 vector, then their dot product is not defined. So in such case, their dot product is 0. Means in order to multiply or in order to find the scalar product or a dot product of two vectors, they must be non-zero is the meaning of this. If one of them is 0, then clearly their dot product is not defined. That means their magnitude is 0. One of the magnitude is 0 means completely this dot product is 0. Okay, see here. A dot B is always a real number. Means the scalar product of two vectors is always going to be a real number. Means it's going to be a scalar quantity. Means it's going to be a one particular constant. So A dot B is always a real number. So we'll look at this again further. What will be the scalar product of two vectors if they are perpendicular? Means depending on the angle, we will discuss few things here. Means if two vectors are perpendicular, means if the angle between them is 90 degree, then what will be their dot product? We will discuss, and it is very important thing to be noted. Okay, now see here. Here A and B are two non-zero vectors which are perpendicular to each other. Means angle between them is 90 degree. Now what will happen to their scalar products? Let's see here. If A and B are perpendicular, then angle between them is 90 degree. As we all know, cos 90 is going to be, cos 90 degrees what? Cos 90 degrees 0. So according to the definition, A dot B, vector A dot vector B is magnitude of A, magnitude of B into cos of 90. So cos 90 is 0. So that's why this full product is going to be 0. So the thing is that whenever the two vectors are perpendicular, their dot product immediately you can write it as 0. Very important. If somebody says that vector A and vector B are perpendicular, immediately in your mind it should flash that their product is 0. So converse is also true, means if their dot product is 0, then definitely vector A is perpendicular to vector B. Means whenever the dot product is 0, they are going to be perpendicular, and conversely if vector A is perpendicular to vector B, then their dot product is also 0. You have to keep this in your mind throughout this chapter. Okay, so whenever this comes anywhere, it immediately implies that their dot product is 0, and whenever their dot product is 0, immediately it should conclude, or immediately in your mind bring that they are perpendicular to each other. Okay, very much important concept. Now look at this. What will be happening if the angle between two vectors is 0? Now see here, there are two vectors, vector A and vector B here. So vector A is there and there is one more vector B, and angle between them clearly is 0 here. Okay, because B is overlapping on A and angle between them is clearly 0. They are all in the same direction. Okay, so what will happen here? Here theta is 0. So we know that cos 0 degree is always 1. So when you apply the formula, A dot B is what? Magnitude of A into magnitude of B into cos of theta. So cos of theta is here what? 0 degree. So cos 0 degree is 1. So you left with magnitude of A into magnitude of B. So whenever the angle between two non-zero vectors is 0, then definitely their dot product is going to be magnitude of A into magnitude of B. So let's discuss further. Now, what will be the scalar product of two equal vectors? Suppose A is a one vector, and if you take its dot product with itself, because A is equal to vector A itself. So if you consider the dot product of vector A and vector A, what will going to happen? Now as we all know that dot product of A and B is defined as vector magnitude of A, magnitude of B, and cos of angle between them. So here dot product of two similar vectors or equal vectors, vector A dot vector A, is nothing but magnitude of A into magnitude of A into cos of angle between A and A. It's absolutely clear that angle between vector A and vector A itself is 0 degree. So cos 0, as we all know, it is 1. So magnitude of A into magnitude of A is magnitude of A square, because the cos of 0 degree is 1. So very much important relation to be noted, that is vector A dot vector A is magnitude of A square. Okay, now see here, what will be the scalar product of these three things, that is I cap dot I cap, J cap dot J cap, and K cap dot K cap. Means the dot product of two unit vectors, two similar unit vectors. So let's ijk are what? Let's see. As we all studied earlier, I cap, J cap, K cap, they are the unit vectors along x-axis, y-axis, and z-axis. Means their magnitude is 1. Now let's see here. I cap dot I cap will be what? So as we all discussed, vector A dot vector A is magnitude of vector A square. So in the same way, I cap dot I cap is its magnitude square. So as we all know, I cap means what? It is a unit vector, means its magnitude is 1. So its magnitude is 1 means 1 square is 1. Similarly, j dot j means again a magnitude of j square. So j cap is what? It is again a unit vector in the direction of y axis. So whose magnitude is 1? So again 1 square is 1. So in the same way, k cap dot k cap is magnitude of k cap square, which is also 1 because k cap is a unit vector in the direction of z axis. Okay, so you have to remember I dot I is 1, j dot j is 1 and k dot k is 1. So next thing is, what will be the dot product of I dot j, j dot k or k dot I? So let's see here. So what will be the scalar product of I dot j, j dot k and k dot I cap? So let's see. See here, as we all know that I cap, j cap, k cap are the unit vectors along x-axis, y-axis, z-axis respectively. And we also know that they are mutually perpendicular, means I is perpendicular to j cap is perpendicular to k cap and k cap is perpendicular to I cap. So angle between I and j is also 90, j and k is also 90, k and I is also 90. So as we all know that if two vectors are perpendicular, their dot product is 0. As I told you earlier, very important thing, whenever two vectors are perpendicular, their dot product is going to be 0. So immediately you have to write. So likewise, I is perpendicular to j, so therefore their dot product is 0. Similarly, j dot k is also 0 and k cap dot I cap is also going to be 0. So in this way you have to think of what is I dot j, j dot k, k dot I, and what is I dot I, j dot j, k dot k. So in this way it is going to be important. Now see here, the scalar product is commutative. There are properties of this dot product. The scalar product is always commutative, means a dot b is always going to equal b dot a, and how it is we will see here. Okay, now see here, as by the definition a dot b vector b is defined as magnitude of a, magnitude of b into cos theta. So b dot a, how will you define vector b dot vector a? It's magnitude of b, magnitude of a into cos theta. So comparing these terms in the right hand side, they are equal. So cos theta, magnitude of b, magnitude of b, magnitude of a, magnitude of a. So here right hand side of equation 1 and 2 are equal. So you can conclude from 1 and 2 that vector a dot b is always equal to vector b dot a. So this is one of the important property of this dot product. So we'll be seeing much more on this. Now, how the angle between two non-zero vectors can be found. Okay, so angle between two non-zero vector. So as we all know that vector a and vector b, if they are non-zero vectors, then their dot product is defined by this magnitude of a, magnitude of b into cos theta. And our aim is to find expression for theta. So cos theta is equal to, okay, so keep this cos theta this side, and if you transfer these to the left, they get divided. Okay, so cos theta is equal to a dot vector b by magnitude of a, magnitude of b. So using this relation, we can find angle between any two non-zero vectors. Whereas even if you can write this also, theta is equal to, if you transfer cos this side, that is cos inverse of this quantity. Okay, so you can find angle between two vectors either using by this formula or directly by this formula. So let's see much more on this. So what will happen if angle between two vectors is 180 degree? Means if theta is 180 degree, then what will be their dot product is the question out here. Now look here. If the angle between them is 180 degree, means vector A is along this direction and vector B is along this direction, means exactly they will have opposite direction. So if the direction is opposite and the angle between them is going to be 180 degree, and what will be their dot product? As we all know that whenever theta is pi, so cos of pi, cos 180 degree is minus 1, that we all know. So simply substituting in this formula, vector A dot vector B is magnitude of A into magnitude of B into cos of pi. So cos pi is minus 1. So this becomes A dot B as equal to minus of magnitude of A, magnitude of B. So remember that whenever they are intersected at an angle 180 degree, then their dot product is this. So let's move. So these are all basic concepts. Once the basic concepts get cleared, it is going to be very, very simple. And now few more properties of scalar product, that is distributive property. So the dot product can be used as a distributive property. So look at this. Here vector A dot B plus C. Here there is an addition of two vectors and outside there is a dot with vector A. In such case, you can distribute this dot product over the addition. Means you can write A dot B plus A dot C. Means you can distribute this dot over the addition. So this is called distributive property of the scalar product over the addition. So we will be having problem on this. Similarly, there is a one property. If there is a vector like this, lambda into vector A, it's vector B. In such case, you can keep lambda outside and you can just find the dot product of A and B, which is also equal to, either you can write vector A dot lambda into vector B. So you will be studying much more on this in the next video. Okay. Now see here, what very, very important, this is going to be coming in every problem. In most of the problems you will be getting this type of situations. So what will be the scalar product of two vectors if they are given in component form? So component form means in terms of I cap, j cap, k cap. Okay, so the previous formula for A dot B is used when you know the angle between the two vectors. But whenever they are given in terms of I cap, j cap, k cap, means in the form of components, then how their dot product can be found. So very, very important. Let's see here. I have done it. Vector A dot vector B, as this is a vector A and this is vector B. So use the distributive property, means multiply each term with each term of this second vector. So I have multiplied this A1 I cap into full this vector plus B1 j cap dot this vector plus C1 k cap dot this vector. So term by term multiplication, that is dot product. Now see here, the dot product of this and this, A1 and A2 they are the constants, they are the scalars, means they are like lambdas. So according to the previous second property, you can write or you can keep A1, A2 as a constant fixed. Then you can just multiply or find the dot product of I dot I. You can write I dot I. Similarly, A1, B2 are constants. You can write I dot J dot. Similarly, A1 C2 fixed and I dot K dot cap. Okay, so in this way you can write. So similarly you can get multiply these two terms and you will come up with these things. Just look at this carefully, and instead of looking better, you can have your pen and paper, and please try by pausing this video. Now after this, look at this. As we discussed earlier, I cap dot I cap is always 1, means it is magnitude of I square. And we know that J and I and J are there perpendicular to each other. So angle between them is 90. So these are two perpendicular vectors. So their product is going to be 0. Similarly, I and K are perpendicular to each other. So their dot product is 0. So likewise, so these red pairs, this, they are going to be 0 because they are mutually perpendicular. Now you will be left with only these diagonal elements. Okay, so you will be left with B1, B2, J dot J is magnitude of J square. Similarly, C1, C2, K dot K is magnitude of K square. And as we all know, I cap, J cap, K cap are all unit vectors. So their magnitude is 1. So you will be left with A1, A2, B1, B2, C1, C2. Better you take screenshot of this page. Okay. Now see here, this you have to remember. Even if you don't know the proof, doesn't matter. But you have to remember this. Means whenever A and B are given in this form, in the component form, in the IJK form, their dot product is defined as in this way. A1, A2 plus B1, B2 plus C1, C2. That means sum of the product of the coefficients of IJK. So in this way you can define the dot product. So we will see the problem on this. So you will understand better. Look at this. Vector A is given as a 2i cap plus 3j cap plus 4k cap, and vector B is given as 3i cap plus 2j cap plus 5k cap. And you are asked to find vector A dot B. Okay, look at this now. How will you define dot product of two vectors in component form? Because these are given in terms of components. So A dot B is defined as A1, A2 plus B1, B2 plus C1, C2. So A1, B1, C1 are these coefficients 2, 3, 4. And A2, B2, C2, these are A2, B2, C2. Substitute here and multiply. 2 3s are 6, 3 2s are 6, 5 4s are 20. So add them, you will get 32. As I said earlier, dot product is always a real number, means it's a scalar quantity. Look at this. So like this you will get the dot product of any two vectors is going to be a real number, like 32 minus 5 minus 20. Like this you will be getting one number. Okay, see more example on this. So another example, vector A is equal to 3i minus 2j minus 3k. Vector B is equal to this, and find A dot B. So I hope you all do it. So let's begin. Try yourself and look at the result. A1, A2 plus B1, B2 plus C1, C2. So substitute for A1 as a 3 and B1 as minus 2, A2 as minus 2, B1 as minus 2 and B2 as minus 2 plus C1 as minus 3 and C2 as 4. Multiply these. 3 into minus 2 is minus 6, minus 2 into minus 2 is plus 4, and minus 3 into 4 is minus 12. Minus 6 minus 12 is minus 18, plus 4 as it is, and addition of these two gives you minus 14. So this is A dot B. Better you take screenshot of this page. Okay students, here are few problems for your practice, and you have to practice these problems without fail, because it makes you much more perfect in finding the dot product of two vectors. So here A and B are given, so directly can find A dot B. Now here you have to take a little bit care. In this case, 3i, A is given as 3i cap minus 5k cap, means j term is absent here. Okay, so you have to rewrite it as vector A is equal to 3i cap plus 0j cap minus 5k cap. And vector B is, look at this, here I term is absent. So you have to rewrite vector B is equal to 0i cap minus 3j cap plus 4 cap. And then you have to find vector A dot B. So similarly, look at this. So this is again same thing. Here j term is absent, I term is absent. So I term is absent means you have to rewrite it as 0i cap plus 2j cap plus 3k cap. And in the vector B, so which term is absent here? Kth term is absent. Okay, k cap is absent. So you have to write it as vector B is equal to minus 3i cap plus 4j cap plus 0 k cap. Then you have to find vector A dot vector B. So answer for this is, here first term is going to be 0, second term is going to be 0, and answer for this is minus 20. You can note down this. Answer for this second problem is minus 20. And looking at this, here I term is here, I term is not here, here it is. So first term is going to be 0, it is 8. So answer is going to be 8 for this. So better try. So in this way you can find the dot product of two terms. Find angle between two vectors A and vector B, and you are given their magnitudes are root 3 and 2 respectively, and their dot product is also given as root 6. So you are asked to find the angle between two vectors, that is theta is asked. Now see here, according to given, magnitude of A is given, that is root 3, and magnitude of B is given as 2, and the dot product of A and B is also given as root 6. And our aim is to find theta, that is angle between two vectors. And as we all know that the angle between two vectors is obtained by using this relation. Cos theta is equal to vector A dot vector B divided by magnitude of A into magnitude of B. And direct whatever the given quantity is used, just substitute. A dot B is given as a root 6 and magnitude of A is a root 3 given and magnitude of B given as 2. And just multiply, means you can, it's left you how fast or how quickly you can multiply them. First I rationalize this denominator. I means multiply and divide by this root 3. So root 6 into root 3 is going to be root 18, and you can write root 3 into root 3 is 3. So you can write 2 into 3. Now root 18 can be written as, root 18 means what? It's a 9 into 2. So square root of 9 is 3. So you can write as 3 root 2 and denominator as it is 2 into 3. So 3 get cancels. You will be left with root 2 by 2. So cos theta is root 2 by 2. Now further you may simplify it as we all know 2 can be written as root 2 into root 2. So 1 root 2 cancels. You will be left with 1 by root 2. So theta is equal to cos inverse of 1 by root 2, and as we all know that cos inverse of 1 by root 2 is 45 degree, or which can be written as pi by 4. So this is the angle between two vectors. So you must know what is the dot product. So we'll be dealing much more with this in the next video. So please keep watching, and if you like, don't forget to subscribe and press the bell button to get latest notifications. Okay, thank you.